In this video, we study the connective OR of propositional logic, the disjunction, and how to deal with it, how to use it in the proof-assistant Lean. We start by assuming that A, B, and C are propositions. For instance, here A is a proposition. And we will first think about the OR introduction rule, that is, ways how to prove a formula whose main connective is a disjunction, is an OR. For this purpose, we assume that we have a proof of A, and Lean has a built-in constant that is called OR.introLeft, and it takes two arguments, another proposition B and our proof of A, and the output is a proof of A or B. So let's look at the type of OR.introLeft. OR.introLeft is sort of a polymorphic function. It takes, for any propositions A and B, it takes a proof of the proposition A and returns a proof of the proposition A or B. So if we apply it to A and B, we get a function that, given a proof of proposition A, returns a proof of the proposition A or B. What does this look like when we are in the middle of an interactive proof, say, and our goal is to prove A or B? For some reason, we have a proof of the proposition A. Well, the way this looks like is we just type OR.intro left because we have a proof of A. And this connector, as I said before, it takes two arguments, B, an argument B, which indicates the left component, and then we have reduced the proof, we have reduced the goal from A or B, which it was before, to A. And here we can plug in our proof of A that we have. This corresponds to the following inference rule, the left introduction rule for OR, which says that in order to prove A or B, it suffices to prove A. If instead of having a proof of A, we had a proof of B around, and our goal was still to prove A or B, we could make a different choice. We could say, well, in order to prove A or B, it suffices to prove B. Then we would use the right introduction rule. The right introduction rule needs the A as an argument, and then our proof, our goal, instead of being A or B, it becomes B. And here we can plug in the proof of B that we have assumed to have, and our goal is proved. This corresponds to the right introduction rule, which looks similar to this one, but instead of hypothesis A, we have hypothesis B. Okay, this concludes the discussion of what to do in order to prove a disjunction. So what to do when the goal is an OR. How do we use as a hypothesis a formula that has an OR? So suppose we have a variable, we have a proof of A or B, and suppose we want to prove an arbitrary formula C from A or B. How does that work? So let's look first at this constant here that is built in Lean, that is called OR.elim. And OR.elim takes three arguments. The first argument is a proof of A or B. which is called H here. The second argument is a proof of the fact that A implies C. And the second argument is a proof that B implies C. And then this whole expression, that we can put in parentheses to make it clear, this whole expression is of type C. So looking at it in more detail, or.elim is a constant that allows us to prove C given several inputs. So the output is a proof of C, and the inputs are a proof of A or B, and a proof that A implies C, and a proof that B implies C. The intuition here is as follows. Think of this example here. Suppose that C is a given task. You want to put a nail into the wall. And there are two tools that allow you to do that. A could be a hammer, and B could be, well, a bit more improvised, a shoe that you use to hammer a nail into a wall. And now suppose A or B, you can think of A or B as a toolbox that contains one of those tools, a hammer or a shoe, but you do not know which one because the toolbox is closed, you haven't opened it. And the question is for you, can I put the nail in the wall provided the contents of the toolbox? You don't know if the toolbox contains a hammer or a shoe. So in order to understand that you can put the nail in the wall, you have to consider both options. Either the content is a hammer or it's a shoe. So if you can put the nail in the wall with a hammer, and you can put the nail in the wall with a shoe, then you know that you will be able to put the nail in the wall, given the toolbox, independently of what specifically the content of the toolbox is, a hammer or a shoe. So how does this work in an interactive proof? Suppose the goal is C. You want to construct a proof of C, and you have a proof of A or B at your disposal. Well, to do this, you use the OR elimination rule, and the OR elimination rule takes 3 arguments. The first argument will always be the proof of the disjunction. And then you have 2 more arguments that you need to fill in, possibly interactively. The first goal will be a proof of the fact that A implies C. And the second will be a proof of the goal that B implies C. And if you can construct these 2, so we can typically, these things will take some effort. So if you can prove both that A implies C and that B implies C, then you can construct, so let's fill these in. Let's pretend we have proved these. Then you have constructed a proof of C. That concludes our discussion of how to use a hypothesis that is a disjunction.